Section 4.5, Exponential and Logarithmic Functions, Part 7. Compound interest. A woman invests $6,500 in an account that pays 6% interest per year, compounded continuously. What is the amount after 2 years? How long will it take for the amount to be $8,000? Okay, reading through the problem. Sometimes it takes a few times to read through a problem, but once you do, you try to look for key wording. In this example, this is our key wording: compound continuously. If we're compounding continuously, then we're going to use the formula PE to the RT. Okay, so for part A, what is the amount after 2 years? We're investing $6,500. There's our P. Interest rate, remember that we always change that from percent to decimal. So E to the R, and then time 2. We'll get that put into our calculator. If we take 6,500 times E to the 0.06 times 2, that gives us money 7328.73. Okay, let's look at the next part. The next part wants us to find time. How long will it take? So we're going to find time. How long will it take for the amount in the account to reach $8,000? So there's our A. We're going to use the same P and the same R, but we know A and we're looking for T in this situation. Okay, so we have A equals PE to the RT. I need to use that formula because it said compounded continuously. For part B, A is 8,000, P is 6,500, our interest rate is 0.06. This time we're solving for time. How do we solve an exponential function? We isolate it first. So we're going to divide both sides by 6,500. So we get 80 over 65. If I kind of reduce it, I could reduce it more, but let's just leave it like that. 80 over 65 e to the 0.06t. I know our fraction can be reduced a little bit more, but we'll just leave it like that. Okay, so to solve an exponential, we isolate it. After we isolate our exponential, then we have to decide how to get rid of base e. What undoes an exponential? What undoes an exponential is a logarithm, and so we're going to ln both sides. So we have ln of 80 over 65 is equal to the ln of e to the 0.06t. ln and e cancel one another out, and so we have the ln of 80 over 65 is equal to 0.06t, and then to get t, we're just going to take ln of 80 over 65 and divide that by 0.06. Okay, so let's get that into our calculator. The ln of 80 divided by 65, we're going to divide that by 0.06, and we get that t is approximately 3.46 years. Okay, let's look at another one. Nancy wants to invest $4,000 in savings certificates that bear an interest rate of 9.75% per year, compounded semi-annually. How long a time period should she choose to save an amount of $5,000? Okay, so let's sort out some information. We want to invest $4,000, so there's our P. Interest rate, 9.75, so there's our R. Remember R, we always change from percent to decimal, 0.975. How long a time period? So we're going to find T. If we need an amount of $5,000, so there's our A. We just have to decide, is it compounding n times per year or is it compounding continuously? What do you think? Here's our keyword, semi-annually. Semi-annually, if we remember from a few slides back or probably a different section, semi-annually, we're adding in interest twice a year. So we're using n compoundings per year for our formula. Okay, so let's start plugging in some numbers. A is 5,000, so we have 5,000 equals. P is 4,000, so we'll plug that part in. Then we have 1 plus our interest rate, 0.0975, all over 2, since we compounded twice a year, raised to the 2, that's still n, and then T is what we're solving for. Okay, so what do we have? We have 5,000 is equal to 4,000 times this inside of the parentheses. Let's go ahead and get a decimal for that. 1 plus 0.0975 divided by 2 gives us a decimal of 1.04875. Okay, how do we solve an exponential equation? To solve an exponential equation, we first have to isolate our exponential. So to isolate our exponential, let's divide both sides by that 4,000. So that gives us 5 over 4 is equal to 1.04875 How do I solve an exponential? We take its inverse. What's the inverse of an exponential? Inverse of an exponential is a logarithm. So I'm going to use ln, but again, you can always use log. I'm going to take the ln of both sides. Okay, now why I left a little bit of room there is because now I'm going to apply a property that says exponents can be written out front. So I can move my 2t out front. If I'm solving for t, we can divide over that 2. If I divide over that 2, it's gone. But I also want to divide over this ln number. It's just a constant. We'll figure out what it is in a minute. The ln of 1.04875. I'm going to also move over, so we're just left with t. Okay, we divided by 2. That moved it over. And we divided by this ln. We moved that over, and that left us with t. Okay, so let's get that in our calculator. ln of 5 over 4 divided by 2 times the ln of 1.04875. Proper use of parentheses. Make sure you got parentheses around this whole thing so that you keep it in the denominator. And then we get 2.34 years. Okay, that's the end of part 7 and the end of section 4.5.